We've seen how to create references inside of a single function, how to create new names for existing pieces of data, and we've observed that that doesn't seem to be terribly useful. We've seen what happens if we use ampersands to create references in function parameters to pass parameters by reference. And there is one other common use case of references we should talk about now, which is what happens when a function returns something by reference. Now, there are actually a few other interesting uses of references that we can't cover just yet because we need more language features under our belts first. But certainly we should talk about this because it turns out returning something by reference is actually a feature we've already been using secretly for the past few lectures. So in fact, for some of our examples of vectors and strings, we were in fact already using this feature. So it's good to talk about it now. What I'm going to do to begin with is I guess I'll compile this program to prove that it does compile. And then I want to do a sort of trace of it and then talk a bit about that question being posed on line number 9. Okay, so it does compile, and we'll leave it as a surprise what the output is until after we've figured this out. I'll now do a quick trace and write in the output. The output's going to consist of 2 lines, and they're going to say part 1 and part 2. And all I want to do is print out the values of my variables a, b, and c. So I'll actually set that up for myself. A equals, b equals, c equals. All right, so I'm going to begin by setting up a scoping box for main. Now, main will eventually contain 4 variables, but at the beginning of the code, it only contains these 3. So A, B, and C. And all of them are ints, and they are the very predictable numerical values that we've grown to know and love. And then I print everything out. Okay, so that's a freebie. So I print out A is 6, B is 10, and C is 17. And then I do this. And you'll notice that what I'm doing here is I'm calling this function, and it's taking its parameters by reference. And so what it's getting are the original A, B, and C, not copies, the original. It is then not making any copies of its own and then returning something by reference, and then the result is being assigned to a reference, or a reference is being initialized in main to be the result. So I'm using references all the way through. In general, when you find yourself returning references, this is a very common pattern, for reasons that'll become clear in a few minutes. If you find that you drop an ampersand anywhere along the way, there will be trouble, and I'll hopefully be able to contextualize that at the end of the video. So I'm going to begin by setting up a box for the function. Let's see, that's a pretty ugly box. We'll have to live with it. So I'm going to make an executive decision. The name of the function is getAReference, but I'm going to call it GAR and assume that I sort of know what I'm talking about. It's just a visual device. So it contains these 3 variables. They are named X, Y, and Z. And they're all ints, but they're all being accepted by reference, which means they are not actual real data existing in this scope. They're just new names for data that exists outside. So main, when I'm calling the function on line number 19, is passing in its own original A, B, and C. And what that means is that the first argument of the function is X, and that means that X is A. So although it's not too obvious on the diagram, keep that in mind, that when I create a reference, all I'm doing is giving a new name to something that already exists. X is A, or Y is B, or in this case, Z is C. They're just new names in a different scope for those things. Okay, so I create that, and then I guess I should have thought ahead a little bit. On line 19, I am also going to want to initialize some variable Z. And Z isn't really a variable, I guess. It's a new name for something that exists. It is a reference, so I'll just color this in, pending, determining exactly what it's going to refer to. Okay, so getAReference, I've got everything set up. I'm ready to start executing on line 9. And the only thing in getAReference is line 12, return Y. But notice that because it's returning a reference, I'm not returning a copy of the data in Y, I am returning the original. So what gets sent back here is Y, and Y is this thing in main called B. So what gets actually returned on line 19 is a reference to B. I don't even want to draw this as pointing to Y, because Y is B. Okay, so this happens and then the function ends. The function already returned its value, it ends. Now, I'm not actually going to erase the full scoping box because I want to prove a point in a minute related to that question on line 9. When the function ends, though, I'm going to just finish up this trace. So when the function ends on line 20, I write z equals 1,000. Okay, well, z is b. That means that now b equals 1,000. And then on line 21, I print everything out. So a is 6, b is 1,000, c is 17. And I guess we could now run this to see, because we've all been held in suspense. And sure enough, there it is. A is 6, b is 1,000, c is 17. I want to rewind, though, for a minute. So let's take the code back. Let's take the diagram back to the state it was in right before the function returned. And that would have b would still have the value 10. And these would all still refer to the variables in the scope of main. There we go. And what would happen if I did this? So if I uncomment these two lines, and now inside of the function, I create a local variable. Notice that the variable called result is created just as an int. It's not a reference to anything. So I'm initializing result to be the value of y. Okay, well, y is this, which is 10. So result contains the value 10. Great, okay. And then I return result. But again, I'm returning it by reference. So what I'm returning is my variable result. That means I'm initializing this reference z to be this thing here. And maybe we can see how this is going to be trouble, because as soon as that return happens, the function ends. And so now I'm actually going to erase the scope. I'm going to painstakingly erase the whole thing. And we can see that there's going to be trouble brewing here, because in main, this variable z I just created now refers to something that is about to cease to exist. Because, of course, when the function ends, its scope and everything inside it gets destroyed forever. It is all gone. And that puts us in a bit of a difficult situation, because in a minute, when I go to set the value of z, so that's going to be on line number 20, what am I setting? So I get to line 20 and I say z equals 1,000. Well, z is, nothing. Z is nothing, because z is a piece of data that no longer exists. So when I try and set it, I've got nothing to set. And if we try compiling this, we'll notice the compiler does notice that something is up. It says, sorry, you can't return a reference to a local variable. Okay, well, it's getting covered up by the text, but you get the idea. And it's then letting me do it, because as we know, the compiler is actually quite compliant. It does point this out. It wants to make it clear that when this goes south, it's not the compiler's fault, but it will let me do it because I've written something that is syntactically correct, even if it's very irresponsible. If I try running the program, though, returning references, then I get this segmentation fault. The program crashes, and I don't blame it, because I try and set a value that doesn't exist. What do I expect it to do? It can't really work around that. And so what's happening here is, of course, I returned a reference to something that then got deleted, and that's a bad idea. So I should be careful. Although it's valid to return references and very productive, I need to be careful that whatever I'm returning is a piece of data that's going to continue to exist outside of the function. So certainly I shouldn't return bits of data that were created in the scope of the function. Okay, so I want to undo all of that. We'll go back to the state that we had it in before, and then we'll just verify that by rerunning it. And I want to make one other observation, which is I want to point out exactly what it was we've been doing all along that has been using returning values by reference in a sort of hidden way. So I'm going to call the function getAReference right here on line number 21. I'm not going to bother with my variable z. Okay, so here I'm calling the function. What does this function return? This function returns a reference to a piece of data. So something that is an actual variable on my diagram. We now know that it turns out it's the variable b. So what comes out of this function is an actual variable. And what can I do with variables? Well, hey, I can assign to them, can't I? So I could write something like this. So I take the value 999 and I assign it to whatever comes out of this. Well, I run the function. It sends me back a piece of data, an actual variable. So it sends me back the variable b, and then I assign the value 999 to that. And that's how we get this strange situation where it looks like we're assigning to the result of a function call. All that's really happening is I've written a function that returns a reference. So what comes out of the function isn't just some number, it's an actual place, an actual variable. And of course, that means I'm allowed to assign to it. And it turns out that the .at function on vectors is just doing that. It's returning a reference to a specific element of the vector, which allows me to use an assignment statement to modify its value.